right, welcome to the last session of today, which is the short-form lightning talks. And we'll kick it off with Thorsten to talk about Emscripten-Forge.
Hi. So I'm Thorsten Beier and I work for Constack, and I will take the microphone. So I'm going to talk about Emscripten-Forge. So Emscripten-Forge is like where we try to arrange a marriage between Emscripten and conda-forge. So this means adding the Emscripten WASM 32 platform to the conda-forge universe. So what is Emscripten? So Emscripten is a compiler toolchain which is used to compile C, C++, or Rust code to WebAssembly that you can run it in the browser. And it's built on top of LLVM. And usually you don't have to write new code to run stuff in WebAssembly. You just take existing C++ application or C applications and compile them that you run in the browser. So this means you can take existing code and do cool, meaningful things like running Doom in the browser, right? Or even slightly more useful things like running an x86 emulator in the browser, or running an x86 emulator in an x86 emulator in the browser. So these are the cool things you can do if you compile stuff with Emscripten. Or even more useful things, running Python or Jupyter directly in the browser. If you have not checked this out, you should go to the Jupyter Lite demo and you can run Python code directly in the browser, which is kind of awesome. So then there's conda-forge. So probably most in the room know what conda is. So conda, mamba, or micro-mamba. So this is, these are language-agnostic package managers for the conda ecosystem, doing more or less the same things. Some a bit slower, some a bit faster. And conda-forge is like a community effort to provide conda packages. So if you want a new package, you just make a new pull request to a certain repository, and then it gets built and uploaded, and the package is there. And the packages are built for all major platforms, so for macOS, Linux, and Windows. Unfortunately, WASM, or Emscripten WASM 32, specifically is not yet supported, and this is where we started our work with Emscripten-Forge. So this is our GitHub repository, and Emscripten-Forge is kind of a poor man's conda-forge in a single repository, where we at the moment maintain 100 recipes, which we compile to WebAssembly. All the packages are built in the CI with GitHub Actions, and then uploaded to our package server, where we just add a new channel, the Emscripten-Forge channel. And at the moment, this is maintained by a few people from Constack. Initially, this project was, by the way, started also with Wolf. So what's the current state of this Emscripten-Forge? So as I said, we have one repository where we maintain all the recipes. If you want to add a new recipe, just make a pull request and hope that it builds. Then since we mostly are interested in compiling Python packages to run in WebAssembly, we need a Python runtime which can call JavaScript from Python and vice versa. And we have also a tiny tool that we can run Python code from a terminal and still run it in the browser and test it. So to install packages, you just run micro-mamba or conda, and you create a new environment, which I here call my environment. And we say the platform is Emscripten 32. We add the specific Emscripten-Forge channel, and then we can just install packages. Like here we install Python, PyBind 11, and whatnot. So what's our outlook and our vision for this? So we want to make Emscripten, or Emscripten WASM 32, actually an official conda-forge target. So we believe that this tiny experiment we did with Emscripten-Forge was a successful proof of concept, and we would like to see the Emscripten target as an optional target to cross-compile, like we do for Apple ARM. And at the moment we are writing a conda-forge enhancement proposal, and hope that this way we can integrate this fully into conda. So, and now I also have a tiny demo to show you what you can actually do with these things. I hope it works. So here we have some code, never mind what this is, but this is just Python code we can change on the fly. And originally I wrote this code for EuroSciPy. But we're not at DuraSci-Pi, so let me change this to PackagingCon. And let's move this a tiny bit. Sorry. And now we can run this, and we see here box2d compiled to Python running in the browser, where we can play around with it, which is quite neat because it's a nice interactive examples where you can teach people how to code quite easy. And let's see, what do we also have? Like physics simulation and so on, and this all runs in the browser. So if you're interested in stuff like that, visit Emscripten-Forge and compile your packages and run them in the browser. That's it. And I assume we don't have time for questions.
Maybe one.
One question? Yep.
Is Emscripten WASM to the same API as everyone uses? Because I've been having so much difficulty interfacing with WASM Rust stuff, and that's maybe my fault. But is Emscripten WASM 32, is that the one, is that the API that everyone's kind of converging on, or is there any other API that they can there? It's small, it should be a small thing, sorry.
So I hope I understand the question correctly. So you were wondering if Emscripten-32 is the one ABI everybody uses and agrees on. Kind of. So there is plain WASM, there is Emscripten WASM, and it's all a weird ecosystem, so to say. But if you want to target the browser, then Emscripten WASM 32 is definitely the thing until WASM 64 becomes the thing. But at the moment, it's a good bet to use that. Yep.
Can also have more questions on Discord as always. And yeah, Daniel, you're up next. For code signing is critical infrastructure.
Hi, I'm Daniel, one of the co-founders of Tauri. Does anyone here know Tauri? Have you used it? I see a couple hands. Okay, it's not about Tauri what I'm here to talk about. Actually, what Wolf said this morning in the introduction about packaging companies reaching out to see if they could present, I resonated with that a little bit when I, entered the call for proposals. I wanted to talk about the last piece of what all of you have been talking about today. I've just had some great experiences meeting people, learning about the ecosystem, and I have some bad news. I represent the apex predator in your supply chains, the users, the people who get applications dropped on their devices. And it's an interesting position to be in because all of the decisions that package managers are making, whether it's Python, Go, Rust, JavaScript, anything else, impact the people that are ultimately using the applications. And that's why I don't have any slides today. I want to take a moment to remind you that the poor application developers at the end of the supply chain have a very real problem. One of them reached out to me in July and said, Daniel, I don't know what to do. I've been shipping Mac OS binaries, Windows binaries, Linux binaries, but now I have to buy a dongle from Microsoft or for Microsoft apps from Komodo or something, spend 500 euro on it, and then I have to buy a machine, a desktop device, run it from my house so I can sign the apps that I send to my users? How does that even work? I'm like, oh, okay, that sucks. I have friends all over the world who are in the open source community building dev tools, and they're like, no, no way, I'm spending 500 euro for a signing key. I just won't sign my apps. It's what's going on. Then they come to our Discord and ask us, well, why is Smart Screen showing up for me? That's the window that Windows shows when you haven't gotten an extended validation certificate to sign the app. How come my app is now being flagged by Windows Defender as probably a virus? I could talk about how the gatekeepers of application signing are the operating systems themselves. We'll leave Linux out because apparently the matrix is so complex of possibilities in the Linux ecosystem that Linux itself can't solve that. So we can just talk about Windows and Mac for a second. The gatekeepers are the operating system manufacturers themselves, and what they've done is they've put themselves in a position where you have to pay to play. Well, Monopoly's a game. I think what's going on is we have a consortium of companies that literally have performed regulatory capture to the point where you cannot escape their influence. Now, in Europe, what's happening with a number of regulations that are entering force, but most specifically the Digital Markets Act, is that these global players are now starting to have to offer up pieces of their empire. It's not going to happen overnight. It's not going to happen in April 1st next year, which is when they're supposed to comply. But I think that the important thing to pay attention to for all of you here and your constituents and your users is that it is possible to hold these kinds of power structures accountable, but we have to stick together. And I think that as I've seen people from Google here, I've seen people from Arch here, I think that the operators of these ecosystems that decide they want to work with open source have to also make it accessible for open source. I could talk for half an hour or an hour about this, but I just wanted to get that off my chest and say thank you, PackagingCon, for having us, and we'll see you on your devices.
Awesome. Now we have two more remote presentations coming in. The first one from Elad, who you've already seen today, Elad Tisha. Securing software package releases with SLSA 1.0.
Hey, my name is Elad, and today we'll talk about Salsa and how it can be used for secure package releases. I'm a security researcher at SciCode, mainly focusing on supply chain security and web application security. Today we'll talk about what is Salsa, why we should consider using Salsa, how to use and implement it, followed by a short demo. When I talk about Salsa, I'm not referring to the sauce or the dance. I'm talking about the Salsa Security Framework. Salsa Security Framework allows producers to ship software with elevated integrity and security, and in the other end allows consumers to verify that artifact and make sure it hasn't been tampered down the stream. Let's break it down. Let's say a producer wants to deliver software to a consumer. The software could be PyP package, NPM, or Docker image. At first sight it looks like an easy task, but when diving into the details, it has many components along the way. For example, a developer making a new release, triggering a build pipeline that will build and push a Python package. Then, a consumer will download and install that package. The problem begins when a consumer wants to verify the code inside a package matches the one in the GitHub repository, and make sure it hasn't been tampered along the way. By generating a provenance document, we will be able to match between the final artifact to the build pipeline and the source code repository. For example, this is a provenance document that verifies two artifacts with their hashes. In the right side, we can see details about the build process and also the source code repository. Details such as the source repository, file workflow, and the git commit. NPM is a great example. NPM now supports Salsa and provenance document by default. Every package with a provenance will have a different section containing the build summary, the specific git commit, and also the workflow file that generated that package. So, let's jump into the demo. In this demo, we have a GitHub repository. the GitHub repository will trigger a new build pipeline. The build pipeline will build and push a new Python package. Let's try to see how a provenance document will help us to match between the final artifacts to the build pipeline and to the source code repository. Now, after a push command, a new Python package will be built and pushed to PyPy. Now, let's try to match between the two artifacts and to the ones in the provenance file. Now, we have the first artifact, and we can see that the provenance document is containing two artifacts. Now, after verifying that the provenance document is containing the two artifacts, let's see what other details we have. Like we saw before, we have details about the job, the build pipeline, and the GitHub repository. Details like the job name, the job ID, the specific build URL, and the git commit that will help us to match between the final artifact to the source code repository. So, this is all for today. Thank you.
And again, you can ask questions on Discord. Elad was already really active on Discord before for his other talk. And the last talk of today is by Rui Chen. And it's called How Does Homebrew Handle Licensing Data?
Hello. Thanks for having me to talk about Homebrew's handling of licensing data in this conference. My name is Ray. A little bit about me. I'm an engineer at the Meetup, currently working on SCIE stuff. In the past 4 years, I'm also working as a maintainer for Homebrew project. A little bit about Homebrew. Homebrew is trying to be an Apple Store for macOS setup, development stuff like that. It supports both source build binary distribution, and it also help launch daemon services and carry funds distribution as well. In the local setup configuration, you can use a brew file. It would be a bundle service to evolve with formula, cask, and etc. Not many people know that Homebrew also supports Linux. We migrated Linux to Homebrew core 2 years ago. And Homebrew is doing the rolling release model, so meaning everything will be latest. Both brew and Homebrew core, and the cask as well. A little bit about Homebrew core. Homebrew core is enforcing to build from source. We don't do binary distribution core. If you need a binary distribution, you can use cask, while you host your own tab. Many people use formula, mostly just doing CLI stuff. Core also supports GUI as well as SDK. Historically, we also do completion formula as well, but nowadays we're trying to combine into formula directly. The current support model we have for core for bottles align with Apple support policy. We only do support the last 3 releases. And one thing to highlight in here is we only enforce license data in Homebrew core. Why do we care about the license? There are 3 things to 3 reasons. First, lots of companies have restrictions about what software they can use. It's kind of like vendor management, and some people also have their personal preferences. Support the open source or not support open source. And most critical reason I can think of is it's kind of like a factor into software commons, and it's kind of like critical to the open source community as a whole. How do we bootstrap the open source license data in the core formula? We firstly add a license field in the DSL. Homebrew core formula is a DSL is by itself, has the DSL definitions in brew. We introduced the SPDX license identifier from the beginning, and using the 3.9 license data set. Right now it's like a 3.22 license data set. Because lots of homebrew core is using GitHub to host their projects, we kind of leverage GitHub license API to do that, and use human reviews to check manually. A little bit about the SPDX. SPDX is a foundation project. It's also ISO standard. For the license list, it consists of two parts: license exceptions. Not every license recognized by SPDX is approval from OSI or FSF. So that's something you need to keep in mind. Like, for example, business source license is recognized by SPDX. Is not open source license at all. License is also living spec. That means we need to continuously monitoring. We need to update the data to get the auditing right. That happens when some formula changes our license in the middle. The early days challenge is mostly just like work with upstream, clear the license information. Sometimes we also need to help enforce the license linkage for like, for example, OpenSSL stuff, GPL linkage stuff. We also follow the upstream first. We try to help specify project license. If they don't, we just delete the formula instead. And sometimes there is a conflict in the license file because they copy paste it, and in the like a TOML file or JSON file, they have a different license declaration. We also need to correct the license usage, like linkage stuff. From the packaging manager perspective, that's why we are here. We think I think license is also a human thing. License is critical, like I said. License is critical for open source community. We should pay more attention to it and grow the ecosystem. Business source license is kind of like a nightmare. Recently, exception is like a HashiCorp formula. We're trying to deprecate them, but it's painful. The future idea is trying to build some license data repo, also trying to better integrate with SPDX in general. And also like a try to make like 100% coverage. There are some references for the past work. And thank you for listening.
So that's it. That was the first day of PackagingCon. I hope you enjoyed it. And